All right, here we go. So 2.5 quotient rule. We've talked about the power rule, constant rule, sum difference rule, and the product rule. And we are now talking about the quotient rule. So as we've seen before, we've had functions where they appear to be a quotient. A quotient, remember, is the result of division. So if we go back here to some of the notes from the previous lessons, and I look at and I see this one right here. See this right here? So that's a quotient. That's a function divided by another function. And before, what we've done is we've rewritten that. We've either simplified into a monomial, or we've rewritten that as a product of some sorts. And then we can solve for the derivative. Well, now we are going to go straight from the quotient of two functions, and we're going to find the derivative directly. So this is a description of the quotient rule, and if we just dig into this a little bit more, jot this down in your notes here. Okay, quotient rule: f of x over g of x. If we're finding the derivative of this, and I should mention, I know we've talked about this already, but the Leibniz notation. So the Leibniz notation is, where are we? So it would show up like this. So instead of the little prime symbol there, if we had dx of this, so this would be the Leibniz notation, right? So dx of this. And we're really trying to find the derivative. Now, I do have the Newton notation here in the description, so I will go back to just the way it was written before. But what we want to do is, and the way I always teach this is, we always start with the first function or the function on the top, and you take the derivative of that. So derivative of the top times the bottom. So remember how in product rule it was derivative of the first times the second that was multiplied together. Now we're doing the derivative of the top times the bottom. As well, with the product rule, we had a plus here, but we have a minus here for quotient. Okay, makes sense. That would be associated with quotient. So minus the top function, just the top function by itself, times the derivative of the bottom. And then we have to divide that by the square of the bottom function. So it kind of reads like this: the derivative of the top times the bottom minus the top times the derivative of the bottom, all over the bottom squared. And if you say that to yourself 100 times, you'll start to, you'll remember it. And then this big complicated looking rule will be pretty straightforward. So just a little bit of a recall there of the Leibniz notation. So let's just take a look at these two examples side by side. And really, I hope you notice that this function over here, written as a product, is exactly the same as this function over here, written as a quotient. Okay? So we're going to do the product rule here on the left first, just as a reminder of how we did this. And we're going to simplify to find the derivative. And then we're going to test our quotient rule, okay? So the product rule, and I'll just write that above. Remember this from last day. The derivative of two functions that are expressed as a product would be the derivative of the first times the second plus the first times the derivative of the second. So that's the product rule. So if we did that, the derivative of the first would be negative 2 over 6. You can bring this negative 2 down and multiply it, times x to the power of negative 3. So the derivative of the first times the second. Just going to rewrite that second function as it is, plus the first, so that's 1/6. And you could put the x down underneath here if you want. I'm tempted to do that. And that's what that really means. Times the derivative of the second, well, which is just 1. And so simplifying this, we have what? 2 over 6, I guess, is 1/3. So we're gonna multiply this into the binomial that's next door there. So we have negative 1/3, and then the x, you add the exponents, so that's negative 1 over 3 x to the power of negative 2 when you add those two exponents. And then we're going to have a minus 1/3 x to the negative 3 when you multiply those through, plus 1 over 6 x squared. So let's get rid of the negative exponents there. And I'm going to have negative 1 over 3x squared minus 1 over 3x cubed plus 1 over 6x squared. To simplify this further, we're going to get a common denominator there, okay? If we can. Just let me think for a second how far I want to go here to compare it to the next one. Okay, well, so let's just simplify this best we can. We can certainly combine all of these together by getting a common denominator, right? So I have to multiply x here and a 2 to the bottom to get to the 6x, 6 with an x cubed. So that's going to give us, what, 2x on top. Oh, sorry, 2x on top is top, over 6x cubed, over 6x cubed, because that's my lowest common multiple of all these three, right? And over here, I need to multiply this simply by 2 to get 6x cubed. So that's 2 over 6x cubed, and then plus x over 6x cubed. So the top now is negative 2x plus x. That's negative x minus 2 over 6x cubed. Okay, so there's my simplified version. I could take a negative 1 out here, I guess, if we really want to do this, I suppose. Negative x plus 2 over 6x cubed. Okay, so either one of those. So that's the product rule. Let's just double check that real quick. Any errors or mistakes there that we need to address? This is not in your textbook, I don't believe. Okay. Let me see. I have this work over here. 2x minus, yeah. That's an x and then minus 2. Yeah, x minus 2. Okay. All right, so let's keep going here with the quotient rule now. We're going to follow our new rule, and you should have that on your paper. I'm going to just walk you through it here. So this equals the derivative of the top times the bottom. So the derivative of the top is 1 times the bottom. That's the first term there. Derivative of the top times the bottom minus. Now minus, you're going to be subtracting a number of terms, so I would use a second set of brackets or whatever. I use the square brackets when I'm already going to use the round brackets, I guess. But so derivative of the top times the bottom minus the top, that's x plus 1, times the derivative of the bottom, which is 12x, all over the bottom squared. So that's going to be 36x to the 4th when you square the bottom. So you square 6 and you square x squared. Okay, you guys good with me there? So up top is 6x squared minus, you can distribute this for a separate step there. So that's going to be 12x squared, and it's going to be plus 12x. And what are we left with up top here? So 6x squared minus 12x squared is going to be negative 6x squared, right? Minus 12x all over 36x to the 4th. Doing a little more simplification, I guess I can take a negative 6x out of here. And what do I get? X plus 2. And if I take a 6x out of the bottom as well, I get 6x cubed. So the 6x's and the 6x's come out, and look at that. I have the exact same that I had using product rule there. Now, it's up to you to decide, I guess, which one looks easier. You're going to have to do both. I would suggest that it's probably going to be a lot easier to do the quotient rule with polynomials and things that it's not easy to write it as a product, especially if you have lots of negative exponents and different things like that. So quotient rule is going to come in very handy. Do you have any questions, though, about that first example? You see both of them there. Any questions there? You good? Okay, am I going too slow? Too fast? Hopefully just right. Okay. So here's an example here from your textbook. So let's do this one. You can use the quotient rule. So I'll write this out so we can see this on the screen. So if I'm going to take the derivative of this right here, that's going to be the derivative of the top times the bottom minus the top times the bottom, the derivative of the bottom, all over the bottom squared. Okay. Now, before I get too far, seeing as I mentioned the textbook here, you'll notice in the textbook, maybe you have noticed, maybe you haven't, and I have mentioned this before with a couple of the rules that I have taught. I'll just clip this out of the textbook for you. So I'll place this over here, and for some reason the textbook shows the f prime as the second term that's multiplied there. Okay, everything else is the same except for this first one. Don't be alarmed. That's still the same. You can multiply, x times y, and y times x is the same thing. So they just would show that a bit different, and I explained this in the last lesson. I always start off with the derivative of the top or the derivative of the first function in product and quotient rules. Just the easier thing for us to remember. So there's a slight variation there, but it's the same formula. Okay, so let's keep going. So if I were to find this derivative then, I would take the derivative of the top, which is 2x plus 2. So 2x plus 2 times the bottom, x cubed plus 1, minus the top just by itself, x squared plus 2x minus 3, times the derivative of the bottom, which is going to be 3x squared. Okay. And then the bottom squared is going to be, now before you go ahead and expand all this, I've mentioned this as well, when we're differentiating in these calculus sort of methods that we're doing, you do not always have to expand every binomial and trinomial that's shown as a multiplication. You don't always have to expand. As a matter of fact, it's probably good to, like for example down here on the bottom, right, instead of me expanding this out, it's good to leave it in factored form, because this really is factored form, okay? So there might be a common factor on the top that you could factor out. For example, notice how I have an x cubed plus 1 here in this first term on top. I obviously have 2x cubed plus 1s down here. Now, there's a chance, if I multiply this through, I don't know, there's a chance that I may have a third x cubed plus 1 over here, which means that you could factor that out, right? So sometimes that's obvious, sometimes it's not, but if you leave them in factored form, sometimes you can tell. Now, I don't think we're going to get an x cubed plus 1 here, so what we're going to have to do is, looks like we're going to have to expand here and then simplify, gather like terms and see what we have. But if you have a common factor in all of the terms, then you might want to just get rid of that right away instead of expanding. So just take a look at that first. But here it looks like we're going to need to keep going on. Okay, so let's expand and gather like terms in an attempt to simplify. So up top here, we can do a little FOIL method. 2x to the 4th plus 2x plus 2x cubed plus 2 minus, do a little expansion here as well. So that's going to be 3x to the 4th plus 6x cubed minus 9x squared, all over x cubed plus 1 squared. Now I can gather like terms, and instead of having two complicated terms, I can just have one sort of, one. I can combine these like terms, so that's what we should do. So 2x to the 4th minus 3x to the 4th is negative x to the 4th, so those are gone now. Let's see, 2x. I guess I don't have any other x's, hey? So just a plus 2x, we'll leave that in there. What about the cubes? Oh yeah, we got some cubes. So 2 minus 6 looks like it would be a negative 4x cubed. Okay, those are gone. And then 2, do we have a constant over here? We don't. So usually we leave the constants to the end. So let's, a negative 9x squared. So it's a positive 9x squared, and then plus 2. You know, if you were just, you know, an A+ student here, and you'll see in the textbook that they'll probably write this in descending order of the variable, okay, which means that they would have x to the 4th first, then they would have their x cubed term next, okay. I'm not going to worry too much about that right now. Because in the factored form, we didn't see any common factors to divide out, we will expand and then gather like terms as best we can. And this is going to be our simplest form. Okay? So as much as you can, try and simplify. And like I say, I won't expect this, but you might see that they'll rearrange their terms so that they have them in the decreasing order of the variables. So that's what I'm just going to do here real quick right now. So that's the way you might see it in the textbook there. Okay. All right. So I tell you what, I want you to do this one on your own. Just take what we've learned so far and see if you can do this. If you can get this one, A1 right, do your quotient rule, and simplify, divide out any common factors that you might find, and just take a moment to do that and give that a try, and I'll reveal the answers to you in a second. Why is this happening? Okay, so here's our solution for the quotient rule. Derivative of the top goes here, times the bottom function, minus the top function times the derivative of the bottom, all over the bottom squared. Don't expand that out, leave that in factored form if you can. And then you might see that there might be a factor that you can factor out. Gather like terms, and you'll notice that there's an obvious greatest common factor here. Factor this if you can. And so here's your